My fabulous chemistry faithful. This is going to be the review of the PBoM Castle Prep to help you study for your test. Before I get started, all of your Castle learnings are set to randomize, which takes the same questions and just mixes up the order they come in. So you will not see these probably in this exact same order when you go to do your Castle Prep. Okay? These are the order that they were in when I made the file to put them in here, and so this is how we're going with it. So let's get to it. Hopefully you can all hear me all right, and you are spared having to look at me because there's no reason to put a video of me down here. You just need to hear what's going on. So change in temperature indicates an increase in average kinetic energy. Increase in average kinetic energy means the temperature is going up. The issue that we have here, though, is that my temperatures are in different units. So we need to, using the reference table, K equals degrees C plus 273. That was one of the first tasks you had to do on the prep, and I can show you what I'm talking about. Very back page of your reference tables. There it is. K equals degrees Celsius plus 273. We got to get everybody on the same page. So it doesn't matter which one you pick, but I'm going to decide to pick taking Celsius to Kelvin because then I just add 273 to every Celsius. So let's go with that. I'm going to start on the bottom and say that 25 plus 273 is now 298. And 0 plus 273, that's easy. That's 273. And 37 plus 273, typing it in my handy old calculator, is 310. And then 15 plus 273 equals 288. Now you can see that only one of them, A, is actually increasing in number. This B is decreasing, C is decreasing, D is decreasing, looks like by about the most. So there you go. The answer is A. Notice what you had to do to solve that, though. During which phase change does water release the most energy? Okay, well, this goes back to the front page of your reference table. Right here. Heat of fusion's 334, heat of vaporization is 2,260. So heat of vaporization is going to be higher. So I got to cross off freezing and melting because these are the 334 guys. And these are the 2,260 guys. So it's definitely one of these. But it says releasing energy. Releasing energy means cooling. Cooling is not vaporization. Vaporization, I have to add heat to make water vaporize. So the answer then is condensation because it's releasing energy. Releasing energy means cooling. Okay. Here's my graph. Which line segment represents boiling? Oh, that's pretty easy. Boiling is always the top flat. That's going D to E. Got it. D. You got to know boiling is the top flat. This one says during interval AB, which is this guy, bottom flat. This is melting. When I'm at any of the flats, that goes for both of these. My potential energy is changing. In this case, because they're heating curves, the potential energy is increasing on a flat. We know that the kinetic energy is staying constant. So potential energy increases. The potential energy of the particles increase. That works. Potential energy decreases. That's wrong. Average kinetic energy of the particles increases. No. Average kinetic, nope, that stays the same. So this only wants one. Some of these answers will want both. Okay. 10 degrees sample at 23 degrees absorbs heat. What will the final temperature be? That implies delta T. This is the two-step problem for a simple multiple choice It's Q equals MC delta T. So I'm just going to start plugging in. I have 209 as my Q. Is going to be MC, which is 10 times 4.18. I don't need to look. I just look C up. I don't need to have it given to me. It's 4.18 times my delta T. Well, I know that 10 times 4.18 is 41.8 times my delta T equals 209. To get delta T by itself, I have to divide by 41.8. What I do to one side, I do to the other. So now in my handy dandy calculator, 209 divided by 41.8. You got to make sure you put that in the right order. That tells me that my delta T equals 5. And notice 5 is an answer choice, but I'm not done. This is that two-step problem. I know that delta T equals temperature final, specifically, minus temperature initial. And I know my delta T is 5. That's going to be my final temperature, X minus 23. To undo minus, I have to add 23. 5 plus 23 is 28 equals X. And look, there it is. Notice something though, which is wrong, but notice 5 degrees is right there. So could you have just jumped the gun? Possibly. And then if you screwed up this math and did 23 minus 5, you'll check it. That's 18. So notice some of the wrong answers on these things are purposely those wrong answers. Okay? So you got to be very careful. You got to know your business. Which equation represents sublimation? Sublimation is a phase change that goes directly from solid to gas. So this is all about phase changes. Sublimation's a tough one. It's not one we know very well. We know boiling better. We know melting better, but we still got to know it. Number 7, which statement defines the temperature of a sample? Temperature is kinetic energy. Temperature is the measure of electromagnetic energy? Absolutely not. Thermal energy? Ooh, that's close. Thermal sounds like heat. Temperature is a measure of average potential energy? No, it's average kinetic energy of the particles. This is the actual definition. Total thermal heat is not temperature. That's your total heat. How are the boiling point of water and melting point of ice affected? This is a question that I just removed from the test. This is very tricky. This is also by decreasing pressure. This is the bell jar that I did for you at the front of the room when I made water boil at room temperature. When I decreased the pressure on the system, I lowered the boiling point. So wherever it says boiling point increases, that's wrong. So the boiling point does definitely have to decrease. The reason why I struck this out is for most liquids. If I decrease the boiling point, I also will decrease the melting point. This one's weird with pressure, and specifically because of pressure, because the water is most dense at 4 degrees, not at 0 degrees. So I actually change and increase the melting point. So I took that, make sure you get it right on your quiz. I couldn't take it off the quiz because I've already assigned it, but I did make sure I took it off the test. And I added a question where you had to calculate the Q again. So it's a simple calculation, but you have to calculate Q. When a sample of gas is cooled, the pressure of the gas on the walls and container, ready, go less often with less force. So if I were to go opposite, if I were to heat it up, I would hit more often with more force. So if I cool it down, it has to go less often with less force. These two in the middle where they're mixed, no chance. You can't. This is one. If one goes up, the other one has to go up. Kinetic molecular theory, which statement describes an ideal gas? There's a few of these questions in here. These are those 5 postulates. Okay, so the gas particles are diatomic. That is not true. Not all gas particles are diatomic. All the noble gases, none of them are diatomic. Which energy is, or I'm sorry, energy is created? The postulate says energy is completely transferred or elastic. There are no attractive forces between gas particles. That's the one we're looking for. That's true. The distance between the gas particles is small. No, the distance is actually very, very big. The distance between them is big. Same number of molecules. Same number of molecules is Avogadro's law. So I need to have the same parameters. So 2-liter sample, I just literally doesn't matter the gas. If I have 2 liters at STP and 2 liters at STP, I now have the same amount. So remember, this was where temperature and volume have to be the same in pressure to get the same number of molecules. 12, according to kinetic molecular theory for an ideal gas, are in random, constant, straight line motion. That is true. Separated by small distances? No. Lots of space. Strong intermolecular forces? No attraction. Collisions that decrease total energy? No. So notice this is the same question as this question, except for the answers are different in a way that only one of them is right. Under which conditions do we act ideally? This is where I need to have no communication between molecules. That's one of the parts of the postulates. So in order to do that, I need them to get moving really fast. If the particles are moving fast, they don't have time to talk and say hey to each other. So that's my high temperature. So I want to get rid of low temperature. But if they're not supposed to talk to each other, I shouldn't make them close to each other. High pressure would make them close to each other. We don't want that. So I want high temperature and low pressure. And I talked you through that one because just memorizing it, you could screw it up. You could go high pressure, low temperature, and that's not true. You need high temperature and low pressure. You need them going fast so they don't talk to each other, and you need them far apart so they don't talk to each other. Now we're going to act more ideally. Which unit is used to express the pressure of a gas? This question is so simple that it's almost not worth it. But if you look on table D, the only one that fits is right here. Pressure is Pascal. All the others are on here, and none of them are pressures. Okay. Mole, Kelvin, joule. Kelvin, temperature. Joule, energy, work. Mole, I don't even think is on here because it's just a counting number. Even if you pick molarity, it's concentration. So there's only one of them that's pressure, Pascal. So that's what we call a rote question. Here's where things get fun. We got those graphs from the lab and from the bell work. P and V, as if I increase the pressure on the balloon is going to shrink. So this is an indirect relationship. Well, this is going up, this is staying the same, and this is going up. So that leads me with this is the best possible choice, even that I taught you it's like that. All right. It's not one-to-one direct, but it's still direct. 16, temperature and volume now. Well, if I increase the temperature on the balloon's going to get bigger. So that is like this. And if I look, that's staying flat. That's going down. That's going down. This is the only one that's going up for direct. Which gas best represents the relationship between pressure and temperature? As temperature goes up, pressure will go up. So now I have this is wrong and this is wrong. Now I have this one's tricky, right? Because I have a curve and it's you can pick the one that's more direct. When I'm stuck picking a curvy one, pick the curvy one. But I can pick the direct one. In this case, I'm going to pick the direct one. A given mass of a gas, if the temperature is increased, its pressure will, well, temperature is kinetic energy. So if they start moving faster, they're going to hit the wall harder with more force, and I'm going to increase the pressure. That is PV or TV, temperature, pressure, TP, like that. There's only one that's inverse, and that's pressure volume. Total number of heat required to completely melt at its boiling point, so the or melting point. So the temperature is not changing. Here I'm using Q equals M, and I'm at the melting point, so H sub F. Melting point is fusion. So solve for Q, plugging these in. It's 347 times 334. Notice 334 is there for you. And then 347 times 334 is, say they rounded their answer, but this is the one the most close. And if I just take a second, if I plug it in and go 347 times 2260, which I chose H sub V by accident, my answer is 78,420, which would be D. So this guy, very close to being a reason why you could pick that. Multiply by the wrong variable, you get multiply this by the wrong variable, you get this. I'm not really quite sure how we got this number, but either way, that's how we do it. One left to go. A sample of water is boiling as heat is added at a constant rate, which describes the potential energy and the kinetic. Well, boiling is the top flat. I see that at the boiling point, the kinetic energy is constant. And I know that the potential energy then has to be increasing because it is a cooling or a heating curve. So I need potential energy increase, which is not this one or this one because it says decrease, decrease. Here's potential energy increase. Here's potential energy increase. Kinetic energy is staying the same. So that's C, that's the top flat. So we just went through all 20 questions. We learned that one of them is super tricky, and I took it off the test so you don't have to worry about that. Let's just make sure you got it right because it is on the quiz. So you got to make sure you get it right that the boiling point goes down when I decrease the pressure, but the melting point will actually go up. So make sure you know that one for the quiz. And with that, you're all good. Study hard for your test.